So for part A, when looking at the highest indoor atrium and dropping a penny off the top, we're trying to find the time. I first looked and found all my values that were given to me in the problem, which included my initial height of 194.15 meters, my final height of 0 meters, or the ground, my acceleration, which was negative 9.8 meters per second squared, or gravity. It's negative because it's going down. My initial velocity of 0, because the person's holding the penny. And in order to find time, I used the formula x final equals x initial plus v final times my time plus 1/2 the acceleration time squared. When you plug in these values, you get that your time is equal to 6.3 seconds. For the next part B, when finding the velocity, you know that your initial velocity is 0 because it's not moving, and I use the formula your final velocity equals your initial velocity plus your acceleration times your time. When you plug in these values, you get that your final velocity is equal to 61.74 meters per second. In converting from meters per second to miles per hour, use a conversion factor of 61.74 meters per second times 1 mile per hour over 0.447 meters per second in order to get 138 miles per hour. Yes, a penny could injure someone traveling at 138 miles per hour. This is why there are laws and rules in place so that people don't get injured from things falling off roofs or really tall things, because that could really hurt someone. Part C, with assuming free fall and the forces acted on the penny as it's traveling. They include air resistance and gravity. I'll show you both part B and part C. This is the diagram. Air resistance is acting against the penny, but gravity is pulling it down with the acceleration vector. That's my 1 cent drawing. Part D, if you were to look in deeper at the penny's fall through the entirety of it, it would not display uniform acceleration due to the penny's movement, meaning like the penny's not going to just stay like this. It's going to flip and turn as it's going. So when a penny is flat and it's falling through the air, there's going to be more air resistance because it's not as aerodynamic. But when it's like this, there's going to be a lot less aerodynamic. It's going to be a lot less aerodynamic, so it's going to be changing its acceleration. I would expect the actual acceleration to decrease as the penny speeds up due to air resistance, because it will reach that terminal velocity, and then air resistance and speed and acceleration will change. So the acceleration will decrease as the penny speeds up due to air resistance.